So in this video, we're going to look at electrical forces and field forces. This is the second example of a field force. The first one was gravity. Remember, with a field force, the force exerted by one object on another, even though there's no physical contact between these. There are some important similarities and differences, but what we're going to be looking at is how do you approach solving these electrical forces and electrical field problems. Now here we have a formula for solving our electric force and field problems. I do want you to remember that our K sub C is our Coulomb's constant. Here we have our charges, and then here we have our distance, and we'll explain that when we get to an example. But as we look at this problem, what I want you to see is that we can cancel out Coulomb's constant on each side. We can cancel out our Q3 on each side, and so what we end up getting is Q1 over R3 1 squared equals Q2 over R3 2 squared. And so this right here is a version of that if we want to solve for Q2, but I just wanted to show you how we got this bottom equation from the top equation. And it's going to be the bottom one that we're going to use on our problems. So here we have, this is problem number 1 on your electrical force and fields problems. So you have a man's beard is 5.33 meters in 1927. Considering two charges, Q1 is 2.5 nanocoulombs and an unspecified charge Q2 are separated by 5.33 meters. A third charge of 1 nanocoulombs is placed 1.9 meters away from Q1. If the net electrical force on this third charge is 0, what is Q2? Alright, we're going to start off with, I showed you this formula on the previous slide, and then we're going to simplify it down by canceling units out. We have Q1, Q3, Q2 is our unknown. Our R31 is 1.9, our R21 is 5.5. So I drew that out over here and I labeled those 1, 2, 3. So our R1 to 3 is 1.9 and our R2 to 1 is 5.3. If I take the 5.3 minus the 1.9, then that's going to give me my 3.43. And that's where I got that number. So we're going to start putting our numbers in here. So our Q2 is our unknown. We can put our Q1 as 2.5 times 10 to the negative 9. Our R32, this area here, I got that number, that 3.43, by taking the 5.3 minus the 1.9. And I put that there. And then my R31 is the 1.9, and you can see I have that over here. Square that, solve, and I get my charge as being 8.15 times 10 to the negative 9 coulombs. So this is a different approach that I'm taking. When you do your homework, there are 12 problems. And so I did number 1 for you, but on number 1 and 2, you're going to use this formula right here. We just did an example. When we get to number 3, we're going to use this equation here. Now, I'm going to stop and go over that with you. This should look familiar because this right here is the old gravity formula, universal gravity. So that G is that constant, and this is where we had the G m1 m2 divided by r squared, that distance. And then this right here, that's your Coulomb's constant, and that's going to be your charge, and then that's going to be your distance. Okay, when we get to 4 and 5, we're going to come up here. Our net force equals our force of gravity minus our force of electricity. But what I want you to notice on these is sometimes we have to sub in. So our formula of force of gravity is mass times gravity, the 9.81. And then our force of electricity, we've got that in here, and we've gone over what that was. Then we get to problem number 6, we're down here. So mass, gravity, and L is length. So this would be the first length, again, Coulomb's constant, charge, r squared is your distance, and then this is that second length. We get to problem number 7, and I may have done an example of that one for you. We get to problem 8. 8 was very long and drawn out, so I did problem 8 solution for you on the next. Problem 9 right here. Problem 10 right there. 11 and 12. And I'm hoping that this will help guide you guys like we used to do in class, where instead of my up the front talking to you, I've kind of given this to you a little bit in advance. So let me know if this works out well for us. Now this right here was just to remind you what Coulomb's constant was, and then to remind you that old equation, force of gravity equals gravitational constant. You'll need that constant on that previous slide when it had G in there. That's the G. And then your distance and your masses.